So for the circuit design, as you can see here, the circuit designs here creates a robotic system that controlled by Arduino Uno. This one. So we have a two ultrasonic sensor that detect objects and doing the stopping point, which guide the robot movement lah. As you can see here, we use a 3-pin uh, two 3-pin ultrasonic sensor instead of 4-pin, which because it's much more easy to use and no complex wiring needed because there is only one pin for the signal. This one. So next is the servo motor is used for the grabbing object. This one, while the photodiode with resistor that detect black color of the pole to drop the object into the bin, which is the ping pong ball. So we have a high torque gear motors that controlled by L29XN H bridge ensure smooth and precise movement. The reason why we use this gear motor instead of a DC motor is because we want to have a much more torque and there will be no there will be less stress on the motor lah. So next is L2C LCD, which displays system status, while push button here doing the starts and reset the robot. So the breadboard here organize the connection that distribute power and ground lah. So this is the much more efficient design that's combine much simplicity, reliable sensor integration, and robust power management that enabling smooth robotic operation.
Assalamualaikum warahmatullahi wabarakatuh and salam sejahtera. My name is Najmi bin Muhammad Rami with matrix number B112410310. Today I'm going to presenting about the programming for the simulation, Arduino simulation for task 4. Now, without further ado, we're going to look at our first line, which is include wire H, include liquid crystal I2C, include servo H. The reason why we need to include all this line is because we need to include from the library into this programming. Without this library, this program won't run normal. And next, we're going to specify the liquid crystal address, which is this one, 0 times 30. Now, how do we know if it's really 020? We just click on this and we look at the properties for the LCD. We set the address at 0 times 20. Okay, and we also set the type is PCM. Now we're going to look at the next one is for defining the pins for all the components. We start with the ultrasonic, which is for ultrasonic 1, which is this one. Okay, we look at the pin we inserted into Arduino, which is 7, so we set it to 7. And for the ultrasonic 2, for the right here, this one will be set to 6, digital 6. So we're going to set to 6. Same goes as for this one. For the motor from the H-bridge control driver, motor control driver, the EN is set to 10, which is this one. So the wire is the orange one. So we insert it to 10 and we define it at pin 10. Same goes for this input 1, which is this one. It goes here at 8. So we set it 8, and input 2, this one, from here to 9. So we set it to 9. For the push button pin, we set it to this one from the terminal here. Go right here. Push right here at 2. So we set it at 2. And this for the servo pin, set it to 11, which is this one. So here, 11. Now, and lastly, we set the pin for the photodiode at a analog 0, which is this one. The purple wire come from the cathode photodiode. Now, we already defined all the pins for all the components. Now we're going to look at the first threshold. Okay, initiate light threshold, which we initiate at 941 value for detecting the black hole at point B. Reason why we set at 941 is this value, it depends our light situation at outdoor, so we need to calibrate based on the experimental. Now we're going to create a servo, my servo, boolean for timing variables. We set it at false, driving ball and test complete. For the void setup, we need to this void setup is where the program starts. Once the simulation start, it will initialize the LCD first. LCD will initiate and it will clear all the data before, and the backlight will turn on, and the LCD set cursor set to 00, which is the address right above here, and it will be the message system ready. LCD print system ready. So we pay the message system ready right here. And now we're going to look at the initialized ultrasonic sensor pins, which we set it the ultrasonic for 1 and 2 at output. And also we're going to set initialized motor driver pins also on output. Now we're going to initialize the push button, and now we're going to look at the my servo. That servo, this is servo right 0, which means the servo will set at normal position, which is 0 degree, which means it is in open position. Now serial begin 960 is basically will run the serial monitor to get the reading from the ultrasonic sensors and also for the diode. Wait for the button press to start while displaying live distance. So this condition is where before all the system starts to run, before we press this button, will be once we start the simulation, we will get the reading from the display based from the programming. So we set the distance. We need to get the distance digital read button pin when it is high. So before we start to push the button, this button and the display, we display some measurement, which means we get the distance A, and also we get the distance for the C. So the reason why we need this is because we need to get calibration before we start to run the system. So it will make easier for us to set how many range we needed. It depends for the ball and also for the point C stopping. And we need to send distance to serial monitor. It is basically same as the display, but we changed it serial. And we're going to need delay, which means it will update every 200 milliseconds on the reading. Now we're going to look at right here. So once the button is pushed, this program will run, and we set it to 0 which means this one is get to clear, and the system will start to activate it. and it will be delayed for 1000 seconds, and it will clear back to get the another message, which is distance. And next we're going to look at the void loop here. This is where all the programming will start. So also we also need to initiate the distance for A and C. So we need to get the distance to get the reading on this display, and we also set to LCD to 10 0 for the distance A. Okay, to get the value of the distance on A, and this is basically for serial print. So it will came on this serial monitor. All right. So this is for logic movement. Okay. So now this is where the interesting part begin. If if the test complete, or a test is not completed yet, the robot will start to move to point B to from point B to point A. So the robot initially will start at point B. It will start to move forward. It will start to move forward to point A. So the LCD will show moving to A. So we know the robot is starting to run at point A. Now, if you get a distance A, this distance A, which means from the ultrasonic sensor that we initiate, is less than 150, which means if we get the reading below 150, so this condition will met, and the grabbing ball will true, and then the function will start run with stop molar, and we delay for 1000 milliseconds. And we also update the LCD screen, which we set to 0 1, and it will appear this message 0 1, which is below here, edges under here. So this function we call out, so this servo will start to trigger, and will also delay 1000 milliseconds. After that, after the ball is grabbed, the robot starts to move back to point B, where all the robot initially start. And if the grabbing ball is met, LCD cursor zero is set to 0 1 back again, and will print out another message is moving to B. And then the robot start to move backward. This is a function where the robot start to move backward. I will explain this later. And for the check and for the black hole detection, when it reaches to point B, there will be a black color on the pole. So when this condition is true, we need to initiate the light intensity from the photodiode, and we also need to print out the light intensity reading on the serial monitor. And if the light intensity is more than light threshold, which we set to 1941 something up there, which means this will trigger, and the motor will start to stop, and will start to run this function. And then it will delay for 1000 milliseconds, and also it will update the LCD display. It appears the message with dropping ball, so the ball will drop, call out the function, and will be delayed 1000 milliseconds, and then it will break all this loop, and now it will be focused to another one, which is move to point C. After we drop the ball, the robot starts to move to point C, and we also same, going to set the LCD display to moving to C, and the robot start to move backward again. And to get the point C, we need to get the distance for this from ultrasonic, the other ultrasonic right here. If the value is less than 100, then is more than 100, which is it will start to move backward unless it is less than 100. Then this function will call to stop the motor, and the LCD display is set it to 0 1, print at point C. So you will get the information on the LCD just like before. And once it's done, it will the task complete will set to true, so we know that the robot is completed all the tasks. And now the LCD is set cursor. We're going to set another message to LCD display, which is test completed, so we know the robot is completed all the tests. I'm going to delay 1000 milliseconds. Or else we also can do what we can do is, if we push this button again, it will reset back to the normal condition where all it begin. So the program is, and this function we call out if the digital pin is detected low, and we delay 100 milliseconds. So this for this part, it is basically a function that we set. So I'm going to go through this one by one. So this one is basically a function for the ultrasonic sensor, the 3-pin ultrasonic sensor. Okay, so we get the distance. So this is basically all the program we need to get the reading for the ultrasonic sensor. And this is pin we set it to input. Okay, to get the reading in ultrasonic sensor. So we need to set duration 0.0342 divided by 2 to convert to centimeter. Now for the function photodiode, so we initiate the read light intensity, and this function we create a function for move forward, where the digital right input motor 1 right here is set to high, while the input 2 is low. So and this one is basically a speed we set. So it depends what kind of speed we need to set. And for this one, this function is move backward. So basically it's just opposite from the forward, which is the input 1 we set it to low, and the input 2 we set will be set it to high, and the speed will be also the same. So the motor will move opposite direction from the forward. Now this function is called to stop the motor, which basically is everything set to low, input 1 and input 2, and the motor speed will be also set to 0. Now for the function to grab the ball, so we may create another function for grabbing the ball. So my servo, the servo we just created will write at 90 degrees, which means this will move at 90 degree. It depends what type of value we need to set, either 180 based the mechanism we use for the ball grab, and we need to delay for this 90 degree to complete. And this function is to drop the ball, basically same as this one, but the servo will write at 0. So we know that when the value is 0, it will back to the normal state, which is normal condition. So we know the mechanism will move, the grab will open from the servo. And now we look at the function for reset program. So for this function, the LCD is clear, and the cursor we set to 0 to 0 to get this another message, system resetting, and delay 2000 milliseconds. So the condition we set to everything we set to false, so we know that the everything on the system will restart back to at the beginning. And also we just in case we need to also set the servo at 0, and after that the LCD will clear back and return to the first part, which is the system ready. So basically this one is looped back from here where the function started. So basically that's for That's for all the programming presentation, and that's all for me for this part. So the next part will be presenting by other group members, and thank you for watching this video.
Hi, my name is Afif Shahmi Hakim bin Hisham, and my matrix number is B112410370. First of all, we use our output to be the LCD display. The reason for our pick is because it could display information in real time, including when the robot is running. This is very useful as the robot could be easily monitored and the real-time feedback opens up room for optimization. Secondly, we decided to use the push button to activate the Arduino system, which also would move the robot. Not only that, it is used to reset the system once the task is complete. The reason we choose push button is mainly because of its reliability, as they were simplistic and didn't require complex circuitry or programming to be used.
Okay, hello everyone. My name is Farhan. I'm from group A9. So today I would like to explain about the sensor that we use for the robot. First, here we use the photodiode and two ultrasonic sensor. First, I would like to explain about the photodiode sensor. The reason why we use this photodiode sensor is for detect the black hole and trigger the mechanism to drop the ball into the bin. After the robot arrive at the B point, so the robot will detect with the photodiode sensor the color of the pole. There is two color, and the point B first is black and the others is brown. When the robot is arrived in the B point, there is another colors that is black color, so the robot will stop and drop the ball. So the other sensor is ultrasonic sensor. First, the ultrasonic sensor we use for detect the ball by measuring the distance between the ball and the robot claws. After the ultrasonic sensors detect the ball with the correct position, so after that the robot claws would grab the ball. So the second sensor, the second ultrasonic sensor, is for detect the point C, the point C. So after the robot after the sensor is detect the point C, so the robot will stop immediately. Okay, thank you. Just that for me.
Hi guys, my name is Jason. My matrix number is B112410375. Today I'd like to explain about the motors that we used for this rope climbing robot. Firstly, we use gear motor. We use this motor for the movement of the robot from one point to another. We use gear motor rather than DC motor because it has higher torque, which is easy to handle heavier loads. Next, we use servo motor for grabbing mechanism. It will grab the ball at point C and it will drop it at point B. This motor also has higher torque, which is suitable for grab the heavy objects such as ping pong for this project. Now I'll show you a little demonstration. As you can see, the start point is from point B. The distance from point B to point A is 50 centimeter, while B to C is 30 centimeter. B, you need to press the start button. And system activity is moving to point A. When it reaches point B, it grabs the ball. And then it moves back. Photodiode detects the basket, it will drop the ball. As you can see, once it dropped the ball, it moved to point C. And the task complete.